Hey everybody, this is going to be a video about the series and parallel circuit calculations. So at this point you should have been introduced the Ohm's law formula, which is V is equal to I times R. In order to solve for your V, I, or R in a series and parallel circuit, it's really important to know the difference between series and parallel circuits. So in addition to saying the dimness, the brightness of series kind of dims, whereas the parallel circuit, the light bulb stays the same. Now you have to know the difference between, well, what happens for current in series compared to parallel, what happens to voltage in series circuit to parallel, and also what's the difference between resistance in the series and parallel. So here's a summary of the series circuit. In series circuit, the voltage is added or distributed to all of the resistors. That means that your total voltage is going to be decreased from resistor 1 to resistor 2 to resistor 3. So it all depends on how much resistance or current it gives off. Whereas in the current, it's all the same. So it doesn't matter if the current of your battery, it's going to be the same in your resistance 1, 2, and 3. And the last one is resistance is similar to voltage, where it is sort of the sum of all your resistance together. I know that's sort of confusing, but one good sort of way that I remember is that in a voltage, I know that whenever I set up my series circuit, I can always place my batteries, my 1.5 volt batteries in this manner, right? If I were to put it in this manner, I know that I'm adding the total voltage together. So in that way, I can remember that voltage in a series circuit is added together. Another way to remember is, well, let's look at current. I is for current. I know that current is the same in series. So I just use the first letter to make it CSS or CS. Current is the same in series. That's how I remember it. Because once you remember one, the other circuit, the parallel circuit, everything flip-flops. So instead of being the same in series, well, it's added up. Whereas the voltage actually is the same in parallel. So if you remember one for one circuit, the other parallel circuit or series circuit, it's going to be completely opposite. Okay, let's start off with the calculations. Here you are given the total voltage. You're given 3 different resistors with 3 different resistance, and you have to calculate a bunch of stuff. So right off the bat, you know you have the total voltage. So the total voltage is 60 volts. What else can I figure out? Well, I know that the resistance for a series circuit is the total. So the resistance, the total is going to be the sum of the resistance 1, resistance 2 plus resistance 3. So 17 plus 12 plus 11, that's going to be 40 resistance, so that's 40 ohms. So I'm going to put 40 ohms in here. Can I calculate my total current? Well, yeah, I can. In this case, I'm not going to calculate the current for each individual resistance because I know that in a series circuit, the current is the same. So in order to calculate it, I'm going to use Ohm's law, which is V is equal to IR. And since current is the same for all of them, I'm going to use the total voltage. That's what we're given, the 60 volts. And I'm trying to find or calculate the total current, so I'm going to leave that. And resistance is going to be my total of 40 ohms. So I'm going to substitute these numbers. My total voltage is 60 volts is equal to I, that's what I'm trying to find, times 40. And I'm trying to solve for I here, so I'm going to divide this. So I is equal to 60. I've just basically rearranged this. So 60 divided by 40, which is 3 over 2, or 1.5 amperes. So my total current is 1.5. The unique thing about this is that the current is the same in series. So basically I can use this same current, 1.5, 1.5, and 1.5. And that's it. We basically filled in 1, 2, 3, 4, 5 boxes out of the 8. Now, to calculate the voltage 1, I'm going to put voltage 1 here. I'm going to use Ohm's law. And what am I going to use? Well, I need to calculate voltage. Do I have the current? Yeah, I just calculate the current to be 1.5. Do I have the resistance? Yes, I do, because it's given to you. So that's 17 So 1.5 times 17 is, let me punch in the calculator, times 17, that's 25.5 volts, and that's my first one. And you notice my next voltage 3 is exactly the same step. So voltage 2 is equal to IR, and my I stays the same to be 1.5, and my resistance in resistance 2 is 12. I'm going to put 12. So then I'm going to punch this in. 1.5 times 12 is 18. So that's my second one. Not too bad. And my last voltage is same formula. V is equal to IR. My current stays the same times my third resistance, which is 11. And 11 times 1.5 is 1.5 times 11 is 16.5. So all of this, it looks so confusing in the beginning, but it's actually not too bad, because as long as you understand that voltage is all added up, that means that you need to calculate it while the series is the same. So once you get the current is the same, then everything is just using Ohm's law. So that's your series circuit. Let's look at the next one. Here is a parallel circuit, because you can see that there's more than one path to each resistance. So I'm given my total voltage is 60 volts. In this case, in a parallel circuit, here's my parallel circuit. My my current I is going to be the total. So that means it's the sum of. Whereas my voltage total is going to be the same. So this is going to be voltage is voltage 2. So if you look back in the previous one, for a series one, remember voltage is added up, whereas in parallel, voltage is the same. Whereas the current is added up, the series one is the same. See, it's the same. So that's one difference you really need to know. And for the resistance total, this one's a little bit tricky, because it's actually 1 over is equal to 1 over resistance 1 plus 1 over resistance 2. I'll talk about how you calculate that in 1 second. So in this one, I have total voltage, and I need to calculate, well, let's write in my total voltage right here. My resistance here is 4.3, which I calculated this. To calculate the resistance for parallel is a little bit tricky. The formula is 1 over R total is equal to, now you can see that they're all in fractions. So 1 over 17 is equal to 1, plus, so it should be plus 1 over 12 plus 1 over 11. So basically you have 3 fractions to add together. So I'm just going to add all these fractions, and I'm going to show you the last thing you need to do. So once you added all the fractions, you might get this. You might get a decimal number, or let's see if my calculator can change this into, oh, actually it doesn't work. But you can get a fraction as well. So once you get this number, this is not entirely correct, because this is 1 over RT is equal to 0.233. So in order to get RT back to the numerator, the resistance, you need to change this, and you need to do the inverse. So on your calculator, you see this 1 over X button. You press this 1 over X button, and you'll get 4.3, or rounded off to 4.3 ohms. So basically, you just did 1 over 0.233 to get you 4.33. So that's my resistance. Can I get the total? Well, now, because I have the total resistance, I have my total voltage, I can use my Ohm's law. So voltage is equal to I total times RT. Substitute numbers in. 60 is equal to IT times 4.3. I need to solve for I times T, so I'm going to divide both sides by 4.3, 4.3. So finally, my I total is equal to, let's punch this in, 60 divided by 4.3 is equal to 13.9. This is 13.9 amps. Whoa. So that's 13.9. The beauty of this is that you're going to recognize that the voltage here in parallel is the same. So voltage here is all the same. So I can basically fill in all the voltage of the other ones. So this is going to be 60 volts, 60 volts, and 60 volts. just like series, but now it's flip-flop. So can we calculate the current for the first one? Yeah, we can. So we have the current for total here. So let's try it. So voltage 1 is equal to I1 times R1. Do we have the voltage 1? Yeah, we have 60 because that's voltage 1. It's the same. Do we have the I1? No, that's what we're trying to find. Do we have the resistance one? Yeah, if you look back in this diagram, we have the resistance one to be times 17. So solve for I1. So divide both sides by 17. So 60 divided by 17 is equal to 60 divided by 17, 3.5. So I1 is equal to 3.5 amperes. So that's the first one. So this is similar to series, but then you just have to recognize which one is going to be the same. Voltage 2 is equal to I2 R2. Let's plug all this stuff in. Voltage stays the same, it's 60. I2 is what we're trying to find, and R2 is 12 ohms. So that's 12 ohms. So solve for I2, so that's going to be 60 divided by 12. I believe that is 5.0 amps. That's my I2. So that's 5.0. And last one, it's getting a little bit messy here. So V3 is equal to I3 R3. And if you plug in all the numbers, you're going to find out that, hey, all the steps are very, very similar. Yeah, once you have all this stuff down, so R3 is here, everything is pretty straightforward. So I3 is 60 divided by 11, which is 5.5, if I round up to 5.5 amps. So notice, I know it seems like there's a lot of calculations, but the important thing for you to recognize here is this. Know what's unique about parallel circuit, know what's unique about series circuit, and once you have those figured out, then break it down. What's the total for each of them first, and then fill in the table about which one stays the same, and then you use Ohm's law to calculate the individual ones. So if you notice the steps, they're all the same. Calculate the total. I know it's very messy. Calculate the total first, and then figure out which ones are the same. So in parallel circuit, remember voltage is the same, so I fill these ones in. And then I use Ohm's law to calculate the individual ones. And that's your series and parallel circuit calculation. So thanks for watching.